Hello everyone. Our today's topic is predictive analysis in data analytics. So, predictive analysis is one of the cornerstones of modern data science, helping businesses, researchers, and analysts uncover patterns, anticipate future trends, and make data-driven decisions. Now, the goal of predictive analysis is not just to analyze past data, but to gain insights that enable better decision making in the future. It's used in a wide range of industries: retail, healthcare, finance, and beyond, providing more powerful insights that improve operations, marketing, and overall strategies. So, let's start here with the introduction. So, predictive analysis uses statistical algorithms and machine learning to predict future outcomes. That means predictive analysis leverages statistical algorithms and machine learning techniques to predict possible future outcomes based on historical data. It's all about looking at patterns in past data and using those patterns to make educated guesses about what will happen next. So, like I said before, the goal here is to provide actionable insights that can help individuals or organizations make informed decisions by forecasting future trends and identifying patterns. Now, predictive analysis is about transforming raw data into something meaningful, something that informs decision making and strategic planning. For example, it's used in predicting customer churn, which means identifying customers who are likely to leave a service, allowing businesses to take preventive action. And then in finance, predictive analysis helps anticipate stock prices or recognize trends in sales forecasts to optimize inventory and marketing efforts. These predictions don't eliminate uncertainty but significantly reduce it, and it offers a competitive edge in various fields. Okay, so now here let's explore some of the key techniques used in predictive analysis. um, so these are the primary tools that analysts leverage to make sense of data and create useful models for prediction. So first is regression analysis, which we learned in our previous lecture. So this is one of the predictive analysis. So regression analysis is also a predictive analysis. So here regression analysis is a powerful statistical method used to predict continuous values. For instance, predicting sales numbers for a future month, or estimating the cost of a house based on variables like size and location. It helps in understanding relationships between variables and determining how changes in one variable impact another. So if you recall the previous lecture from regression analysis, we went over some examples of regression analysis. Then we have classification. So classification is used for predicting categorical outcomes. Think of classification as the process of assigning labels to data based on its attributes. Examples include like predicting whether an email is a spam or not, or categorizing customer feedback as positive, neutral, or negative. So this is called classification. Then we have time series forecasting. So this technique involves analyzing data points collected or recorded at specific time intervals to forecast future trends. For example, um, predicting stock market prices, temperature trends, or seasonal sales trends. It's essential for understanding how variables change over time and planning accordingly. Then we have clustering. So, clustering is about grouping similar data points to discover patterns in the data that may not be apparent otherwise. For example, clustering can help identify different customer segments in a market based on purchasing behaviors, allowing for more targeted marketing efforts. Okay, then lastly we have decision trees and random forests. Now these are methods used for both classification and regression. A decision tree is a flowchart like structure that helps make decisions based on the attributes of the data. And random forests, on the other hand, are an ensemble technique that involves multiple decision trees working together, and we can say it provides more robust predictions by averaging out the results of the individual trees. So these techniques are fundamental in deriving actionable insights from data, enabling businesses and organizations to be proactive rather than reactive. They are also the backbone of many modern technologies, from recommendation systems on streaming platforms to fraud detection systems in banking. So here we'll see the importance of data and features. So the quality and choice of data as well as the features derived from it are critical elements in the success of predictive analysis. So let's take a closer look at why data and features are so important. First, data quality. High quality data is essential for building reliable and accurate predictive models. If the data is inconsistent, incomplete, or inaccurate, it will lead to unreliable prediction. So you might heard these lines so many times up until now, but this is a very important point to consider when you have when you're using predictive analysis, or when you're using any other visualizations or any other techniques. For any kind of technique or any kind of analysis, your data has to be accurate and complete and consistent. So that's the main goal for to get a desirable results. So there's a saying like garbage in, garbage out, which is particularly relevant here. Without good quality data, even the most sophisticated algorithms will struggle to deliver meaningful insights. Now, next we have feature selection. So, not all data is equally valuable, and that's where feature selection comes into play. Now, it is a process of choosing the most relevant variables to include in your model. So by selecting the right variables, you can improve the model's accuracy and make it more efficient. For example, if you are building a model to predict house prices, including features like square footage, location, and the number of bedrooms will be much more useful than including irrelevant data like the color of the house. So I hope that makes sense, that why feature is so important, feature selection. Then we have feature engineering. Now sometimes the data we have isn't enough. or we need to create new features that help capture trends better. Uh, now, where now here we use the feature engineering, which involves creating new features from existing data. So, for instance, if you have a data set with dates, uh, you can extract features like the day of the week or the month, which might reveal trends based on seasonality. So here how you can do the feature engineering. Now lastly, we have example for sales forecasting. In sales forecasting, for example, choosing features like seasonality and marketing spend, which can make a significant difference. Seasonality helps capture the effect of different times and so different times of the year on sales, while marketing spend is a critical variable that often directly impacts sales volume. Now, so here in predictive analysis, choosing and engineering the right features, it is very important and can make or break a model's performance. The more thoughtful and informed we are in selecting and processing features, the better our predictive models will be. So here we have, so in this section we'll go through some of the most commonly used predictive analysis or predictive models and algorithms that are integral to predictive analytics. Each of these algorithms has specific strength and that make them suitable for different types of problems depending on the data and the desired outcomes. First, we have linear regression. So linear regression is one of the most fundamental techniques for predicting continuous outcomes. It helps establish relationships between variables by feeding a line through the data points. So, for instance, you might use linear regression to predict a company's monthly sales based on advertising expenditure. So, next we have logistic regression. Now, despite its name, logistic regression is used for classification tasks, not regression. It's often used for predicting binary outcomes, like determining whether a customer will churn or not. Logistic regression works by estimating probabilities and applying a threshold to make a classification decision. Okay, third we have random forests, which are an ensemble method that combines multiple decision trees to improve the accuracy of both classification and regression tasks. They are very effective because they reduce the risk of overfitting by averaging the results from many trees, thereby increasing the robustness of predictions. Okay, next we have support vector machine. So SVM is a very popular algorithm, particularly effective for classification problems. SVM works by finding a boundary called a hyperplane that best separates data into different classes. So it's commonly used in scenarios such as image classification or text categorization. Lastly, we have neural networks. So neural networks are used in deep learning and are well suited for dealing with complex data patterns and relationships. They are especially powerful when working with large data sets where traditional algorithms may struggle. Neural networks are behind many advanced applications such as speech recognition, image analysis, and natural language processing. So these models and algorithms are the backbone of predictive analytics, each serving a unique purpose depending on the problem at hand. By selecting the right algorithm and applying it to high quality data, we can make predictions that guide effective decision making. Okay, so in predictive analysis, it's crucial to measure the effectiveness of our models to ensure that they are making accurate predictions. Uh, we'll see the key evaluations metrics used to assess model performance. Each metric plays a specific role depending on whether we are working on classification or regression task. Now, first is accuracy, which is the simplest evaluation metric and represents the proportion of correctly predicted instances to the total number of instances. It's commonly used for classification problems where we want to know how often the model is right. However, accuracy alone can be misleading, especially if there is class imbalance where one category significantly outnumbers the others. Then we have precision and recall. So when dealing with imbalanced datasets, metrics like precision and recall are more informative. So what is precision? Precision tells us how many of the positive predictions made by the model were actually correct. It is particularly useful in situations where false positives have a high cost, such as in fraud detection. Then recall. Recall measures how many actual positive instances were correctly identified by the model. It is useful in situations where missing a positive instance is costly, like in medical diagnosis. Next, we have mean squared error. We also learned this on the regression analysis lecture. So it is used for regression tasks to measure the average of the squares of the errors. In other words, it calculates how close the predicted values are to the actual values, penalizing larger errors more heavily. The lower the MSE, the better the model's performance. Okay, next is ROC-AUC curve, which means receiver operating characteristics and area under the curve. So receiver operating characteristic curve, which is ROC curve, and the area under the curve, which is AUC curve, both are used to measure a classification model's performance at various threshold settings. The AUC provides an aggregate measure of performance across all possible classification thresholds. A high AUC value means that the model can distinguish well between positive and negative classes. Then, lastly, we have cross-validation. Cross-validation is a technique used to generalize the model's performance. The data is split into multiple training and testing sets to ensure the model isn't overfitting on a particular subset of data. This helps validate that the model performs well across different samples and hasn't learned peculiarities unique to a single set. So these metrics allow us to evaluate our models reliably and ensure it is making informed and accurate predictions. It is important to choose the right evaluation metric depending on the problem we are solving and the consequences of errors in the model's prediction. Okay, now we'll discuss some of the practical applications of predictive analysis. So it is not just a theoretical concept, it is actively transforming many industries and helping businesses and organizations make better decisions. So here are a few prominent use cases. Customer churn prediction. This is one of the major challenges for companies, especially those offering subscription based service. Um, so, customer churn, when customers stop using their service, they face this challenge. So, predictive analysis can be used to identify customers who are likely to leave based on patterns in their behavior, allowing the company to take proactive measures to retain them. For example, offering targeted promotions or personalized assistance to those at high risk of leaving. So let me describe more about it. So let's say you have Netflix subscription, but you are likely to cancel your subscription, but the company will not. How the company will know that you are likely to leave or they are going to lose a customer? How they will know? So they can use this some kind of predictive analysis to identify those customers who are likely to leave based on their patterns in their behavior. So if they are not watching movies very often, or they are not watching movies like last 2 months they didn't watch anything, for example, so they can just see the patterns. They can study the patterns, and then they can make a decision, and they can offer them some those targeted customer. They can offer some personalized assistant, so that they will take another chance to stay on the subscription. So this is how customer churn prediction works. This is a huge help for those companies, so that they will know that, because if suddenly most of the customers leave the subscription, then the company will be in loss suddenly. So they have to have some kind of predictive analysis to hold those customers. Then we have sales forecasting. Now, predictive analysis plays a critical role in sales forecasting. So by analyzing historical sales data, seasonality, and other contributing factors, businesses can accurately forecast future sales, allowing them to plan inventory and manage resources, and set realistic revenue targets. Then we have fraud detection. In the finance and insurance sectors, fraud detection is a key application of predictive analysis. So it can analyze transaction data and detect patterns that may indicate fraudulent, that can be suspicious. So the models flag anomalies that deviate from typical behavior. So it just find out, and it's a study, and it find out some strange behavior that company can use to identify and stop fraud before it escalates. Healthcare. So in healthcare, which is another domain where predictive analytics is having a profound impact. Now, predictive models can be used to assess the risk of dizziness, or the risk of diseases, by analyzing patient data, lifestyle factors, and medical history. These insights help healthcare providers offer personalized treatment plans, allocate resources effectively, and take preventive measures to improve patient outcome. So let's say for a nutritionist, if the nutritionist need to have create a diet chart for a patient, the he or she needs to have a history of lifestyle or eating history or lifestyle of the patient to make the right diet chart or diet plan for them. So here when they can use the predictive analysis. Okay, finance. In finance, predictive analysis is widely used for stock market forecasting and making investments decisions. Now, by analyzing historical market data, economic indicators, and financial news, predictive models can help investors anticipate market movements and make informed decisions to maximize returns. Then we will now see a case study predicting customer churn. So let's take a deeper dive into a practical example. Now, the main goal of this case study is to predict which customers are likely to leave a service using historical data. By identifying these customers early, the company can take actions such as targeted promotions, personalized outreach, or improved support to reduce churn and retain more customers. Like I said about Netflix. Now, to predict customer churn, we need relevant data. In this scenario, the data set includes information such as customer demographics, service usage patterns, and customer support interactions. So each of these data points can provide valuable signals. For example, a significant reduction in service usage or repeated negative interactions with support could be a sign that a customer is dissatisfied and may be planning to leave. So I will give you another example. Like nowadays we have a like button or dislike button in Netflix. So if you don't like the movie, some customers have the option to dislike or like the movie. So let's say if the company is getting most of the movies, let's say a customer is disliking most of the movies in Netflix, so it could be a pattern that he or she will soon leave the company or just stop the subscription. So that could be a reason. Now, on the data set, we have the customer demographics. That means from which countries, how many countries we have, like from the customer where from which country they're using the service, and also their age group, their some kind of behavior. Service usage patterns means how often they watch movies, or how often they how long they watch Netflix. These are the patterns, or how many times in a week they watch movies in Netflix. These are the patterns for service usage. These are the patterns called service usage patterns. Then customer support interactions, which I just already said that for example, a significant reduction in service usage or repeated negative interactions with support could be signs that a customer is dissatisfied. Now, what can we do? The next step is to build a classification model to predict churn. In this case, we can use logistic regression or random forest. Logistic regression helps estimate the probability that a customer will churn based on their attributes. And random forest, on the other hand, is an assembled learning technique that combines multiple decision trees to make a more accurate prediction. It is particularly effective because it can capture complex interactions between variables. The predictive model was trained and evaluated, and then it achieved an 85% accuracy rate with high precision and recall. This means that the model is able to correctly identify a significant proportion of the customers who are likely to leave while minimizing false positives. Now, the conclusion here is that predictive analysis can be incredibly effective in helping businesses retain customers by identifying those at risk of churning, which allows for targeting. This allows for targeted intervention strategies such as offering discounts, improving customer support, or making personalized recommendations to keep these customers engaged. So, in this way, predictive analytics not only helps with reducing customer churn but also contributes to increasing customer lifetime value and enhancing overall business profitability. Okay, so in predictive analysis, advancements in technology and data science have given rise to more sophisticated modeling techniques that offer enhanced performance and accuracy. So let's explore some of these advanced predictive modeling techniques. First is gradient boosting machines, GBM. So these are like a type of ensemble learning method that builds a model in a stage-wise fashion where each subsequent model attempts to correct the errors of the previous ones. Popular implementations like XGBoost and Light GBM, these are widely used to enhance prediction performance. GBM works by combining the strength of multiple weak learners, typically like decision trees, to form a stronger prediction model. These methods are known for their high accuracy and are frequently used in data science competitions as well as real-world applications such as credit scoring and customer segmentation. Now next is Bayesian networks. So Bayesian networks are probabilistic graphical models that represent sets of variables and their conditional dependencies. They use the concept of Bayesian probability to update beliefs based on evidence, making them ideal for situations where decisions need to be made in the face of uncertainty. It is useful in various applications such as risk assessment, medical diagnosis, and any scenario where we need to model the probability of different outcomes based on a set of inputs. They help in understanding the relationships between different variables in a complex system. Okay, third is AutoML. AutoML, which is automated machine learning, is a recent innovation that aims to automate the process of model selection and hyperparameter tuning. AutoML tools such as Google's AutoML or H2O.ai that helps data scientists to create effective predictive models more efficiently by automatically identifying the best models and parameters for the given data. This is especially useful for those who are new to machine learning or when working with large datasets where manually finding the optimal parameters can be very time consuming. Now, it also helps democratize data science by making predictive analysis more accessible to people with less technical expertise. Now, these advanced techniques allow data scientists to handle more complex problems and data sets while providing highly accurate predictions. Okay, handling imbalanced data. When working on classification tasks, it's common to encounter imbalanced data sets where one class significantly outnumbers the others. Um, this imbalance can lead to a model that performs well overall but fails to properly identify the minority class, which is often the class of the greatest interest, like fraud detection or disease diagnosis. So let's discuss two popular methods to handle such situations. SMOTE, which is synthetic minority over sampling technique. So it is widely used technique to address class imbalance by generating synthetic samples for the minority class. Instead of simply duplicating minority samples, SMOTE creates new instance by interpolating between existing minority class samples, which helps to improve model learning. By doing this, SMOTE aims to provide a balanced dataset that allows the classifier to better identify patterns associated with the minority class. This method is particularly useful in scenarios like predicting fraudulent transaction, where the number of fraud cases is typically much smaller than the number of legitimate cases. Then the next one is cost sensitive learning, which involves adjusting the cost or weight assigned to misclassifying different classes. The idea is to prioritize the minority class by assigning it a higher misclassification cost. So this approach encourages the model to give greater attention to the minority class during training. It's an effective technique when the cost of false negatives is significantly higher than the cost of false positives, such as in medical diagnosis, where missing a case of serious illness could have severe consequences. Cost-sensitive learning can be implemented in many algorithms by altering the objective function to penalize misclassification of minority class instances more heavily. Okay, so model interpretability and explainability. As predictive models become more advanced, they often become more complex, resulting in what we refer to as black box models. These are models whose decision making processes are not easily understandable by humans. However, in many applications, particularly in sensitive areas like healthcare and finance, it is crucial to understand why a model made a specific prediction. This brings us to the concept of model interpretability and explainability. So, here we have SHAP, which means S happily additive explanations, and LIME, which is local interpretable model agnostic explanations. So SHAP and LIME are two popular methods for interpreting complex black box models. SHAP is based on cooperative game theory and assigns an importance value to each feature contributing to a particular prediction. It provides a consistent way to understand the contribution of each input feature. Then LIME, on the other hand, is used to approximate a black box model with an interpretable model locally around the prediction of interest. It helps in understanding how specific features affect the model's predictions by building simpler interpretable models for individual predictions. So both Sharp and Lime enable us to make machine learning models more transparent, helping stakeholders such as medical professionals or financial analysts understand the logic behind each prediction. Then we have explainable AI, which is an emerging field that emphasizes the importance of transparency and interpretability in artificial intelligence. The idea is that models should not only provide accurate prediction but also explain how and why they came to their conclusions. In areas like healthcare, having interpretable models is critical because doctors need to trust the decisions that AI models make, especially when it comes to life and death situations. So, similarly, in finance, regulators may require companies to demonstrate why a particular credit decision was made. So, making model interpretability legally and ethically important. XAI provides a framework for making AI systems explainable, thus enhancing trust and accountability, which is especially important in domains where users need to take actions based on AI outputs. So, the importance of interpretability cannot be overstated, as it helps build trust in AI systems and ensures that they are used responsibly. As the data scientists, our job is not only to develop accurate models, but also to make sure these models are understandable and trustworthy for all stakeholders involved. So here next we have model optimization and hyperparameter tuning. So in machine learning, the performance of a model can often be significantly improved by adjusting the hyperparameters settings that are not learned from the data but set before training. So let's see some common techniques for model optimization and how we can effectively tune hyperparameters to achieve the best possible performance. So first is grid search and random search. So grid search is one of the most popular techniques for hyperparameter tuning. It systematically searches through a predefined set of hyperparameters to find the combination that produces the best results. Essentially, you define a grid of hyperparameter values and the algorithm evaluates all possible combinations. While it is comprehensive, grid search can be computationally expensive, especially with many parameters or large datasets. So, where random search provides an alternative that can be more efficient. So instead of trying all possible combinations, random search randomly samples a specified number of combinations. This technique can often find a good set of hyperparameters in less time compared to grid search, making it useful for problems where computational resources are a concern. Okay, next we have Bayesian optimization, which is an advanced method for hyperparameter tuning. So, unlike grid search and random search, Bayesian optimization builds a probabilistic model to represent the relationship between hyperparameters and model performance. It then uses this model to choose the most promising hyperparameters to evaluate next, aiming to find the best values in fewer iterations. So, Bayesian optimization is particularly useful when evaluating the model is computationally expensive. and you want to minimize the number of iterations needed. Okay, so here once a predictive model has been developed and optimized, the next critical step is to deploy it in production so that it can start providing value in a real world environment. So let's look at what it takes to effectively deploy a model and keep it running smoothly over time. Model deployment in production and monitoring and maintenance. So first, deploying a model in a production environment involves making the model accessible to end users or integrating it into existing systems where it can provide predictions. So there are several best practices and techniques for deploying models, including using cloud performance. Cloud services like Amazon Web Services, Azure, and Google Cloud provide the infrastructure and tools needed to deploy and manage model efficiently. So these platforms offer scalability, security, and the ability to handle large amounts of data and multiple users. Next, we can have deployment techniques. A common approach is to deploy the model as a REST API, allowing other applications to send data to the model and receive predictions in real time. Alternatively, models can be integrated directly into applications or used for batch processing on a scheduled basis. Then we can have containerization. So Docker is often used to package models along with their dependencies into containers, ensuring that they run consistently across different environments. So next we have model monitoring and maintenance. So deploying the model is not the end of the process. It is important to continuously evaluate the model's performance and maintain it to ensure it remains accurate and reliable over time. Once a model is live, we need to monitor its performance metrics such as accuracy or precision to ensure it's still making good predictions. Changes in data over time, known as data drift, can lead to model degradation, which requires retraining the model with updated data. Next, predictive models need to be periodically retrained with new data to keep them relevant. For instance, a model predicting customer preferences might need to be updated frequently as customer behavior evolves. Then automation tools can help schedule retraining, evaluate model updates, and seamlessly replace all older versions with new ones. So lastly, we can say effective monitoring includes logging model inputs, outputs, and the decision-making process. In addition, setting up alerts can notify the team when model performance drops below a predefined threshold, allowing quick intervention. Okay, so as we utilize predictive analysis to make decisions, it is critical to address the ethical implications and the potential biases in the models we create. Ignoring these considerations can lead to unintended consequences that could be harmful or unfair to individuals or groups. So let's see two key areas: algorithm fairness and ethical concerns. First of all, predictive analysis or models can inherit biases present in the data they are trained on. If historical data contains bias, whether it's related to gender, ethnicity, age, or socioeconomic status, then the model may perpetuate or even amplify these biases. For example, a hiring model trained on biased hierarchical or historical recruitment data might learn to unfairly favor candidates of a certain background while discriminating against others. It's important to conduct biased audits on the data used and evaluate model outcomes for fairness. Techniques like reweighting data using fairness aware algorithms or testing models' performance across different demographic groups are methods to help ensure that the model treats all individuals fairly. Um, Beyond fairness, there are broader ethical considerations when building and deploying predictive models, such as privacy. These models needs personal require personal data, and it's important to consider how this data is collected, stored, and used. So, respecting users' privacy and ensuring that data is handled securely is paramount. Individuals should be aware of and provide consent for their data to be used, especially when predictive models are being used to make decisions that affect them. Transparency in data collection and model use builds trust. So, sometimes predictive models can be misused intentionally or unintentionally. For instance, predictive policing models that suggest which areas are at risk for crime could lead to unfair targeting of certain neighborhoods. Ensuring that these models are used responsibly and considering the potential negative impact they might have on people's life is crucial. So, addressing ethical considerations and bias in predictive analysis not only relates to more accurate and trustworthy models but also helps avoid harm and ensure positive impact. So, that's all for today, and thank you. Let me know if you have any question.